So hello guys, this is another question from IIT JEE PYQ. The question is from the Advanced 2013. Advanced 2013. And the question is based on the concept of that work power energy. Here is the question. The work done on a particle of mass m by a force that is given like this. Here k is a constant of appropriate dimensions. When the particle is taken from this point a comma 0 to 0 comma a along a circular path of radius a about its origin, okay, in the xy plane, then we have to tell what is the work done by this force, right? So here the expression of this force is what? F vector is equal to k into x divided by x square plus y square to power 3 by 2 I cap plus y divided by x square plus y square to the power 3 by 2 into j cap direction. So this is the value of force here, and here we are taking a particle like this is our xy plane, this is our x, this is our y, and this is a circular path, let us suppose, and the radius of this circle is what? This point is a comma 0 and this point is 0 comma a, okay, and this is our origin. So here I can write that from this equation of circle. So the equation of circle will be equal to x square plus y square is equal to a square. So in the force I can substitute these values. So the expression of this force I can directly write. I will be writing here the value of a is equal to what? Root under x square plus y square. Okay, so I can substitute the value of root under x square plus y square in this force. So the expression for this force will be equal to what? F vector is equal to that k into x divided by this root under x square plus y square is equal to a. So this will be a cube, okay, I cap, plus similarly this y divided by a cube into j cap. Okay, so this is our expression for this force. Now I will be using the simpler method here, that this is an variable force and we want to calculate the work done by this force along this path. So I will be assuming a small line element, like for dx length, dx vector that will dl vector that will be equal to dx I cap plus dy j cap. So I will be calculating the small work done for along this line, along this small line element, and then I will be integrating over the these situations as we have been given these limits from a comma 0 to 0 comma a. Okay, so for the small work done dw, what is the value here? That is f vector dot dl vector, okay, and we have to integrate it. So we are putting the values here, that what is the value of f vector? This is k by a cube into x I cap plus y j cap dot product with the value of this dl vector is what? Dx I cap plus dy j cap, right? So here okay, so now we have to take the dot product here, that is what? K by a cube into x dot dx plus y dot dy, okay. So this is our value and we have to take up the limits here. The value of limits for x is what? From a to 0, and the value of limits for y is what? From 0 to a, okay. So now we have to substitute, we have to integrate this and we have to substitute these values. Then it will be equal to k by a cube into the integration for x dx is what? X square by 2, and the limits is from 0 to a, plus the integration for y dy is what? Y square by 2, and the limits are from a comma 0 comma a, okay, and the these limits are from a to 0 for x, okay. When we will solving it, then this equation will be equal to k by a cube, and this will be equal to negative of a square by 2, and this will be plus a square by 2. So this will be cancelled out and the value of work done will be equal to 0 here, okay. So work done by this force will be 0 along this path from taking the particle from the points a comma 0 to 0 comma a, okay. One another method also we can opt here, that the value of force we are getting here, that f vector is equal to k divided by a cube into x I cap plus y j cap. Okay, so we can see that we can check this force is conservative or not. So we can take the perfect differentials also, or we can directly find out the curl here. Del cross F will be equal to 0 for this force. So from here we can say that this force is conservative in nature. Okay, that means conservative in nature, right? And we can also see that this radius vector we always write r square is equal to uh, x square plus y square, and if I differentiate both sides, then 2r dr will be equal to what? This 2x dx plus 2y dy, right? So here this force will always be acting in this radial direction, radial outward direction, radially outward direction. Okay, so here if I draw that diagram, that this is our circle here, this is our xy plane xy, and this is our circle here, and we are taking this particle from this point a comma 0 to 0 comma a. Okay, and the field due to this force, if I say in another terms, so this force is always in radially outward direction at every point of xy. Okay, and the displacement of this body is always along perpendicular to this force, like it is in this direction, it is always perpendicular. Or we say that the potential as we know that this is the equipotential surface in this field of this force, and this is the equipotential surface. I can also write equipotential surface, potential surface. And also we can prove that this displacement of this particle is always perpendicular to this f vector. So this is the ds vector. So here, and this is also an equipotential surface. So potential at point a comma 0 will be equal to potential at point 0 comma a. That means what? Work done by a conservative force is equal to change in the potential energy actually. Okay, so here potentials are same, so we can say that work done by this force will be equal to 0. So this is an actually logical reasoning, we can also think about it, and the usual method we can also use here as I have used earlier. So the correct option will be equal to what? 0. That is option number D. Okay.